Welcome GeoTrig. This is on 4.4, trigonometric functions of any angle. Let's begin. So this might look familiar, but it's pretty much is, but it's a little bit going on here. So we have an angle that's on the coordinate plane here. And this is just another way to represent the 6 trigonometric functions. I know you know that it's opposite over hypotenuse, but it doesn't always work that way because sometimes the angle theta is more than 90 degrees. So we don't really have a right triangle. But the same 6 trigonometric ratios still apply. So here's an example of what I mean. So you got this point P at 1, -3, and the angle theta actually goes down to this point. It's actually, the terminal side's in the fourth quadrant. So what are the 6 trigonometric functions of theta? Well, it's not, if we're talking the sine, we're not talking this theta, we're talking the outside theta. So the sine of theta here is not going to be y over r. It's actually going to be, well, it is y over r. So it's y right here over r. And what's the length of y right here? Well, y is going to be -3, and x is going to be 1. What is r? We have to use our distance formula. So r is going to be the square root of 1 squared plus 3 squared, so 9. So r is going to be the square root of 10. So sine is y over r, which is going to be -3 over square root of 10. Another way to write that, if we don't want to leave square roots in the bottom, multiply top and bottom by square root. So it's going to be 10 over -3 radical 10. Cosine is going to be the x value over r, so it's going to be 1 over square root of 10, which is the same thing as square root of 10 over regular 10. Now the tangent is sine over cosine. So if we're doing sine over cosine, that's -3 over radical 10 over 1 over radical 10. Radical 10s just cancel out, so it's just -3 over 1, or -3. Cosecant is just going to be the reciprocal of sine, so I can just say it's square root of 10 over -3. Cosine is going to be square root of 10 over 1, or just square root of 10. And cotangent will be -1/3. All right. So you know what the 4 quadrants are in a coordinate plane, and quadrant 1, both x and y are positive, and this quadrant 2, it's negative, positive, and these are both negative and 3, and in quadrant 4, it's positive, negative. Well, we can use those properties to figure out if sines and all our trig functions are positive or negative. So in quadrant 1, everything's positive, and that makes sense. In quadrant 3, but see, in quadrant 2, your sine and cosecant are positive only. And that makes sense because of those are the y values here, and all y values are positive. Now in quadrant 3, your tangent and cotangent are positive. Everything else is negative because those are sine over cosine or cosine over sine, and negative over negative is going to be a positive. In quadrant 4, you have your cosine and secant are positive because those are the x values, and everything x is positive. So sometimes we can apply that to certain properties here. So if I ask, if sine of theta is less than 0, so it's negative, and cosine of theta is less than 0, so negative, which quadrant will the angle theta lie in? So sine is negative, and that's whenever the y values are negative, so it's going to be in these two. And cosine is negative when the x value is negative, so that's these two. Where's the overlap? That'll be in quadrant 3. So that angle theta is in quadrant 3. Here's a big vocabulary word, reference angles. So reference angles it's a positive angle here. It's a positive acute angle that's formed by the terminal side of theta and the x-axis. So it's basically the angle that'll get when you go from the terminal side of some angle. It's the leftover angle that'll take you to the x-axis. So if your theta is this distance here, your reference angle is going to be right here. If your theta goes past the x-axis, so past 180 degrees, the reference angle is that. And this one, if it goes in the fourth quadrant, your reference angle is right here. Notice it's all got to be positive angles. So your reference angle will always be positive. Even if this is in the negative side or we're backtracking, it's always positive. All right, so let's find some reference angles. So I found a reference angle of 210 degrees. The easiest way to do this is you got to understand that, like, what quadrant that terminal side will lie in. And 210, no, this is 180. So now 210 is going to be 180, basically plus another 30, right? So I'm going to take that 210. I know if this section's 180, this little section right here for our terminal angle has got to be 30. So it's going to take 30 degrees to get back, so the reference angle will be 30 degrees. For 7 pi over 4. So 7 pi over 4 is going, and I think the easiest way is just to recognize where that is on a unit circle. At 180 degrees, same thing as pi. 7 pi over 4 will be not at pi. It's farther than that. It'll actually be halfway between 3/4 pi and 2 pi. So it's going to be right here. So if it's halfway, what you're left with here is 45 degrees, or if we might as well keep it in radians, that is going to be pi over 4. So that is our reference angle. For negative 240 degrees, we're going backwards. So this will be negative 180, and then I have to do another 60 degrees here. So this, even though this was negative 240, this little chunk right here is going to be 60 degrees. But your reference angle is not negative 60, it's just regular 60 degrees. And for last one, this is 3.6. When you don't have a degree sign, assume that is radians. So 3.6 radians, one way to figure out the reference angle is we can just subtract 1 pi, or 180 degrees. So subtract 3.14, and what you're going to be left with is 0. Let's see, that's going to be 46. So 46 is your reference angle. 46 hundredths radians. All right, next thing. Find reference angles outside of 360 degrees. Well, you just, instead of, I couldn't draw it on a unit circle, just kind of find a coterminal angle that's between, or that's less than 360 degrees, or 2 pi. That's also positive. So somewhere between 0 and 360 degrees, or 2 pi. Whatever you're doing it in. So if I wanted to find 665 degrees, a reference angle, I'm going to subtract 360 from that. And what you're going to get is 305. So I got to find reference angle for angle at 305 degrees. That's 180. I know this is 270, and so it'll be another 35 degrees here. So if that's another 35 degrees here, I know what's left and right here for my reference angle is going to be 55 degrees. So my reference angle for A would be 55 degrees. All right, let's do some examples. So pause the video. All right, in this case, P is going to be 2, 1. If P is 2, 1, then R is going to be the square root of 2 squared, so 4, plus the square root of 1 squared is 1. So R is going to be the square root of 5. My sign is going to be R over Y. So it's going to be square root of 5 over Y, and Y is 1, and X is 2. So it's going to be 5 over 1, or just square root of 5. Cosine is going to be square root of 5 over 2. And tangent is going to be sine over cosine. So square root of 5 over 1 over square root of 5 over 2. So what happens there is these radicals cancel out. So I got 1 over 1/2, which is the same thing as 2. For cosecant, the reciprocal of sine is going to be 1 over square root of 5, which if you multiply by radical 5 over radical 5 is radical 5 over regular 5. Secant, the reciprocal of cosine, so it'll be 2 radical 5, and I don't like radicals in the bottom, so it'll be 5 over 2 radical 5. And cotangent, the reciprocal of tangent, so 1/2. Next one. Pause the video. All right, if sine of theta is positive and cosine of theta is positive, name the quadrant in which angle theta lies. Well, sine's positive in these ones, and cosine's positive in these ones, so the overlap is in quadrant 1. Next one. Pause the video. So we got to find the reference angle here. So I'm going to subtract, I can subtract 180, and 200 degrees minus 180 will be 20 degrees. If you drew that out, 200 degrees is like right there. So your reference angle is that 20 degrees. For 21 pi over 5. So that's bigger than 2 pi. So I got to find something that's coterminal to 21 pi over 5. So I'm going to subtract 2 pi from that. And that subtracting 2 pi is the same thing. I could do it over 5. That'll be 10 pi over 5. So you get 11 pi over 5, but that's still not less than 2 pi. So subtract another 2 pi. All right, it's 10 pi over 5, so I'll get pi over 5. So pi over 5, if you actually graph that, pi over 5, this is pi over 4. Pi over 4 is like 45 degrees. So pi over 5 is somewhere really close to that. The reference angle for something that's pi over 5 is actually just pi over 5, because that's how you get to the x-axis. Negative 500 degrees, let's add 360. Got to get a coterminal angle, so it'll be negative 140 degrees. And if you're graphing that, I know this is negative 90, and negative 80 is the whole distance, so negative 140 is going to be about there. So you're going to be left with 40 degrees right here. So your reference angle is going to be 40 degrees. All right, that's it.